Hi, Mr. Richards here. Today's algebra lesson is on the Pythagorean Theorem. Our first key concepts involve those properties of a right triangle. And if I just go ahead and draw in a right triangle here with our one right angle, we have hypotenuse and legs. For hypotenuse, this is the side opposite the right angle in other words, it's this side right here, the side that is opposite the right angle. What about legs? Well, legs are the sides of a right triangle that form the right angle. And that is these two sides are our legs. So our key concept box, the Pythagorean Theorem, if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So c squared equals a squared plus b squared. And actually, oftentimes you hear this as well, a squared plus b squared equals c squared. It's the same thing, just written the opposite way, where, again, c here is our hypotenuse, where a and b are our legs. So being able to identify which sides are my legs and which side is my hypotenuse is very important when it comes to finding missing lengths in right triangles. And so in our first example, we have find each missing length. If necessary, round to the nearest tenth. I think it's important to label our sides first. Our legs are those that form the right angle. So our legs are here at A and B. And that side that's opposite the right angle is C. And so we can rewrite our Pythagorean theorem, a squared plus b squared equals c squared. And now we substitute numbers in. For a, we can just put in the 18 squared plus b was 24 squared equals, well, c squared. And quite frankly, you can interchange your a and your b. You could call a 24 and b 18. That order for this type of question does not matter since they're both legs. 18 squared is 324 plus 24 squared is 576. And that's going to equal c squared. The sum of 324 and 576 is 900 equals c squared. And now to solve this, we need to take the square root of both sides. And so the square root of 900 is plus or minus 30 equals c. Now, of course, since we're dealing with lengths here, we're not going to have the negative measurement. So our answer is simply 30 units. Again, we do not need to use the negative here. It's distance, so it's going to be positive. In example 1b, we once again have find each missing length, if necessary, round to the nearest hundredth. So let's go ahead and label our sides. Those that form the right angle are a and b, and that side that's opposite the right angle is side c. And if we start off with the Pythagorean theorem, a squared plus b squared equals c squared, notice in this question we're missing one of the legs. So we'll substitute our numbers in, 9 for a. We do not know our b, so we can just leave that b squared equals, this time we know our c, is 16, so 16 squared. A common mistake with the Pythagorean theorem is that we just throw in the two numbers on the a and the b no matter where those numbers are. So you need to be able to identify, all right, I know my a, I know my c, but this time I'm looking for a leg, I'm looking for b. 9 squared is 81 plus b squared equals 16 squared is 256. And if we subtract 81 from both sides so we can isolate the b squared, this cancels. We're left with b squared equals 175. Once again, we can take the square root of both sides, and b is going to equal plus or minus, using a calculator now, 13,228. I'll take it to the thousandths place. So when I now solve, b is equal to the positive 13 and 23 hundredths, as that 8 is going to round that up. In our second example today, the diagonal of a television screen is 32 inches. The width of the screen is 21 inches. Find the height of the screen. In these types of problems, I think it's very good to draw yourself a picture. And so we have this nice television here. The diagonal of the screen is 32 inches. So just kind of draw in the diagonal of the screen here. I'm going to label this 32. Now, the width is 21 inches. So here's my width at 21 inches. Here's a right angle. And so what we have formed here are two triangles, and we just need to use one of these triangles in order to find this missing side, the height of the screen. And so if I go ahead and label my legs A, B, and my hypotenuse is C, I can use the Pythagorean theorem to find the height of this television. So A squared plus B squared equals C squared. We do not know the A, so that's going to just stay A squared. We'll substitute in 21 for B, so 21 squared equals 32 squared for C. And now we just solve. A squared plus 441 equals 1024. We can subtract the 441 from both sides of our equation to isolate the A squared. So A squared is equal to 583. Next, we can take the square root of both sides and have A is equal to plus or minus 24 and 145 thousandths. And once again, since we're rounding to the nearest hundredth, we need to write our answer to the nearest thousandths to see if we need to round up or stay the same. And in this case, we do need to round up. So our height is going to be equal to the positive answer here, 24 and 15 hundredths, and we're given a unit here, so inches. So whether you're solving for a missing leg or a missing hypotenuse, we've solved for A, we've solved for B, and we've solved for C. You can still use A squared plus B squared equals C squared and solve for your missing variable. Now in the second part of this lesson, we deal with the converse of the Pythagorean theorem and the Pythagorean triple. The converse is defined as the statement formed by exchanging the phrases after if and then of an if-then statement. Recall that the Pythagorean theorem in words states if a triangle is a right triangle, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In the converse, we have if a triangle has side lengths a, b, and c, such that c squared equals a squared plus b squared, then the triangle is a right triangle. We've switched the if and the then. So instead of saying again, if a triangle is a right triangle, then a squared plus b squared equals c squared, we're saying if a squared plus b squared equals c squared, then it's a right triangle. And of course, if a squared plus b squared does not equal c squared, then it's not a right triangle. And so what we can use is this converse of the Pythagorean theorem to determine whether or not side lengths will form a right triangle. And for that, we have the Pythagorean triple. These are counting numbers that satisfy the Pythagorean theorem which of course is a squared plus b squared equals c squared, where c is the largest number. And that is important to note, that c is your hypotenuse and that is going to be your longest side. And an example of this are the numbers 3, 4, and 5. Since 3 squared plus 4 squared, does it equal 5 squared? Well, 9 plus 16, 5 squared is 25, so yeah, 25 equals 25. So this is an example of a Pythagorean triple. And so to finish this lesson, we have 2 examples of determining whether or not 3 lengths can be the lengths of the sides of a right triangle. In our first one, we have determined whether 7, 12, and 15 can be the lengths of the sides of a right triangle. Well, let's just draw a triangle. 7, 12, and 15, and it is important to recognize where our longest side is. The longest side is here at 15. That has to be the C. So when I go and test, does a squared plus b squared equal c squared? Is this true? If it is, then these 3 legs or 3 sides form a right triangle. If it doesn't, then, well, they don't. So the 7 and the 12, the 2 smaller sides, you can substitute in for either a or b, and I'll just go 7 squared plus 12 squared. Does it equal 15 squared? 7 squared is 49. 12 squared is 144. Does that add up to be 15 squared, which is 225? Well, 49 and 144 add up to be 193, which is not equal to 225, so our answer is simply no, this is not the lengths of a right triangle. So in our last example, determine whether 33, 55, and 44 can be the lengths of the sides of a right triangle. And again, the first thing you want to be able to do is identify where is my longest side and label that C, so that we can say, all right, with a squared plus b squared equals c squared, I know my longest side has to be that C. And my other 2 sides I can just write in for a and b. A common mistake here, an all too common mistake that I see, is that students will go 33 squared plus 55 squared equals 44 squared, just writing it in the order of the question. That is not the way to do it. You need to identify your longest side. You need to call that C. So now as we're testing if a squared plus b squared does equal c squared, 33 squared is 1,089. 44 squared is 1,936. And is that sum going to be equal to 3,025? Well, yes. It does add up to be 3,025. So our answer, yes, these do form a right triangle. That is it for this lesson on the Pythagorean theorem. Good luck.